In this recording, we are going to go over an example about using KNN method. And as we said, KNN method is a memory-based reasoning technique. It's simple and it's used frequently. Sometimes it produces accurate results. However, it's time-consuming and computationally expensive. As you remember, this method basically works or based on two components. So the first one is standardizing data. The other thing is we are using the distances. Normally we're using Euclidean distances, and it's based on looking for the nearest neighborhoods and the behavior of the nearest neighbors, not neighborhood neighbors. So this is exactly what we are going to do in this example. So let's look at what's happening here. We have social media marketing company, and they are conducting customer or consumer research to see how the income level and age might correspond to whether or not consumers respond positively to a social media campaign. Aaliyah Turner, a new college intern, is assigned to collect data from the past marketing campaigns. She compiled the file with what? How many? We have 284 consumers who participated in the marketing campaigns in the past. We have income in thousands and age, and whether or not each individual responded to the campaign. 1 if yes, 0 otherwise. So the file is in chapter 12, and if you again notice here, I am working on chapter 12 project, so I would like to have everything on one folder and one project. So all of the files, they're going to be like in one folder, in one project, okay? So, and again, I have the data set, it's in my directory here, and it's already my directory, the folder, the project I am at right now. So I'm going to call the data or load the library and data using library readxl, and I'm going to use the function readxl as x. So I'm just typing the title of the name of the file. Then the sheet is social media data. We have two files of the social media. One of them is social media data. So run this one, then we got 284. We have 3 variables. View this. So we have the income, we have the age, we have social media, yes or no, 0 or 1. Because we have different scales, so it's a good idea to standardize the income and age. And we need to make sure that this variable is factor. All of them looks numeric, but let's look at the structure. So all of them are numeric. So before we conduct the KNN, we have to make sure that we include first all of these libraries. So first you have to install all of these caret, gains, PROC, and CAR. If you do caret, make sure that you add dependencies, depends and suggests. We did this before, so I'm going to leave installing packages to you. You can install all of them at the same time, by the way. Install packages. You can do C, you can do caret, comma, gains, comma, etc. It's going to ask me to redo this. I'm not, so cancel. Oops. So you can add all of them, by the way. You can add all of them. So I just include the first two. You can continue. So load the libraries that you have installed. And to perform the KNN analysis, so the first question says, let's do the KNN analysis. And the goal is to estimate classification model for the social media campaign using this social media data and score new consumer records. And this is the idea, is scoring new consumer records. So we have another worksheet that we have age and income. We would like to give them scores for the social media campaigns. Yes or no. So to do this, first we are to the first step is to do what? Is to standardize the predictor variables. And to standardize the predictor variables, we're going to do something we have done before. So first standardize variables. Let's call it my data 1. To standardize, we use a function called scale, as we did before. I'm going to standardize my data, but I'm not going to standardize all of the data because the first column is the response, right? So we are going to standardize the second and the third. So my data, the second and the third only column. So we did standardize this one, so we got a matrix now. This is a matrix. Okay. Now we are going to add the third column for that, right? So we are going to add, now we have two of them, so we would like to add the social media to that one. So I'm going to keep it my data 1. My data 1. I'm going to create data frame. I'm going to add my data as is, my data 1. Then I'm going to add my data from the original one, the social media column, because I have only 2 columns now. So I'm going to add, I'm going to create a new table, data frame, containing the my data 1, the age and the standardized age and standardized income, and I'm going to add the social media column from the my data. Then I'm going to run this. So this one has been updated. Then I'm going to change this column. Actually, just before this, let me fix the name. Fix the name, just call names. I'm going to use call names. So let's change the name of the third column. Okay, so I'm going to call names. So be specific here. What name you would like to change? I would like to change the name in my data 1. And the name of which column? Now you have selected the data set. I'm going to select the third column. Because call names, okay, what if let me just copy this and let me just show you what's happening here. Let me drop this here, okay? Call names give me the names of the columns. We have 3 columns, so there's the first number, there's the first value, there's the second value, there's the third value. It's like a vector, right? Call names is like a vector. So if you actually choose the third one, it's going to return this one, right? So this one, I would like this one to be what? Social media. Okay, then let's run this. If you run this, let's go back here. It's social media now. Okay, after that, as I said, in my data 1, if you look at the structure of my data 1 again, what you see, numeric. So this is my response variable. We have to have what? Factor. So when you do KNN, this variable has to be factor. So change the response to factor variable. Okay, it's categorical. So my data 1, it's the one that we are working at right now. The social media, change it to as factor. The same variable, my data 1 at social media. So it's going to be factor. So if you run this again, if you run the structure again, or if you can change, you can choose a class to check the its factor 0, 1, right? Now what we are going to do, now I have my data 1, which contains ready data. We prepared the data. We have 284. We have 3 variables. Now we are going to partition the data into 2 parts. Training data, 60%, 40% for the training data, for the validation data, sorry. So the training data is going to be used to generate one or more than one model, and the validation data is going to be used to evaluate the performance of the models. Okay, but within the training data, when we generate models, we are going to use cross-validation techniques, the K-fold cross-validation technique. So the first step now, we are going to do data partitioning. Before I start doing data partitioning, remember in the previous examples, we used a function called sample. So sample, give me random indices. It depends how many you would like to get, 60%, 30%, 40% index, etc. So the function sample give you random indices, we have another function. It's much better than the sample. It's called create data partition. This is used to randomly split the data into the way that we would like, 60% for training and 40% for the validation. And the question is, why we are going to use this function, the outcome variable. What does this mean? This function makes sure that both training and validation sets have a representative distribution of classes. So you want to make sure that you don't want to get into a problem when you're randomly using the sample function and having so little cases from, let's say, class 1. So that's why we are going to use a create data partition. So the first step, we're gonna partition the data into 2 parts, and we will explain the next step. So now we are going to, so for all of us to be in the same spot, so let's use seed 1, okay? And let me use, I'm gonna call it index. Create data partition. Once you start with this function, you're going to have many arguments, okay? We are going to do 3 arguments only. We're gonna fill out 3 arguments. The first argument is going to be my data one. What is the data that you would like to partition? I would like to do my data one based on the social media. This is what we said. So the second argument is going to be, what is the proportion of the data to be used for the training? For the training, we're going to use a probability. It's going to be, the partition is going to be 60%. P equals 6%. The format of the output, the format. So is it list? Do you want to see it as a list? False. No, not list. Okay. Because we would like to get the index as vectors of indices, not as a list. Okay. And this is easy because if you have vector, then you can use it in the data frames. Now we have indices, and 60% will be chosen for the training. So that's why we're going to have train. As we did before, there's nothing new here. My data 1, again, brackets, my, or index here, right? And validation, it's going to be my data 1 minus index. Okay. So for the training, we're going to have only the indices that we have got. So let me just run this guy just to show you. We can do command enter. These are the indices have been chosen randomly to be taken from the my data one. So these indices now I'm going to select them from my data one to be my training, and the rest, my negative index, they're going to be chosen to be for the validation set. So if you run this, then we got the training and the validation set. Oh, I made a mistake, right? I have comma. Yeah, because this is my my training is a data set, is a data frame. Data frame, we have to have like a comma because the first one belongs to the rows, second one belongs to the columns. So the rows, I would like to have these indices in my training, these observations, and these what is left for my validation. Run again. So this is my training, this is my validation. So my training, we got 171 observation. We have 3 variables. For the validation, we have 113 observations, again with 3 variables. After we got the partitions, now we have 2 of them. For the training, we are going to train the models. We are going to use 171 observations to train the model. And how we are going to do this? We are going to implement 10-fold cross-validation method. Within the building the model, we are going to do this within 10-fold. So it's kind of, we are going to build many models, right? and we're going to choose the best one. Not us. R is going to do all of this. So how to implement the 10 folds cross-validation technique? If you remember, we called something my control here. So this is the 10 folds, which is using a train control. We used this before, which is method equals CV. We have number of folds is going to be 10, right? So these are 10 folds. After that, we are going to specify the K value. How many K? We set KNN. How many observations you would like to look around of the new observation? 2, 3, 4, 5, from what to what? From what to what? Because you're going to build many models. So we would like to choose multiple values of K's. So R choose the optimal number of K. As many K's you are including as many minutes or time or time is going to be spent searching and looking, and so it depends on your machine. These are simple data. I mean, small data. We have small data sets, so it's not going to be like complicated. But let's use K from 1 to 10. K from 1 to 10. Okay, and we are going to use a function called expand.grid. Expand.grid create a data frame. Someone's going to tell me why we did not use data frame function. For example, let me just show you this. So let me call it my grid. Okay. Expand.grid. K equals C from 1 to 10. So this is from 1 to 10. So this is the C. This is the K values. Okay. Why expand.grid? Expand.grid. Actually, it's okay. It creates data frame with one column named K in this case, and it contains all possible combinations of the values 1 through 10. And when we do the training, or when we run the model, we would like to look at all of the combinations. We would like R to see all of the K values. Okay, so that's why we create this K, or this expanded grid. Now we are going to implement the KNN. So set seed again, so we get the same answer as all of us. We're going to call it KNN fit. It's a train. This function we have used many times. When you do cross-validation, K-fold, we use a train, and the train contains so many methods. And now we are going to use a few arguments. Number one, you have to specify what is your formula. The formula is social media. Tilde, everything, comma. After that, you're going to tell me from where, which data you're going to use to build this model. It's data, train, right? It's from the train. We're going to do training. We're going to train the models. Then you're going to tell me what method you're going to use. If you remember, we used GLM method in the past. So this is not GLM, this is KNN method. After that, you're going to tell me what kind of cross-validation technique you're going to do and how many folds, which is train control. Right? This one will be my control. This one, my control. The very last thing is going to be the tune grid. And the tune grid is going to be what? As we said, tune grid is going to be my grid. So we're going to try all of the combinations of values of K from 1 to 10. We don't have only one K value. We have many of them. Then we would like to choose the very best one. Okay. So after that, we are going to, have we run this? Did we run this? My control? My control, yes. My grid, no. Expanding grid. Argument is not a function. Argument is not a function. Why is that? I added dot before that, so let me keep the dot here. So let's run this, and let's do the KNN fit. So let's run this now. So we got different values of what we see first, we see that we have 171 samples, we have 2 predictors, and for the response we have 2 classes, which is 0 and 1. We implemented cross-validation techniques, 10 folds. The folds they have used like this. These are the numbers of the sample sizes. So for the resampling, so this is the very best one. Look at the accuracy rate. 60%, 56%, 63%, 65%, 63%, 63, 60, 63, 66, 65. And we would look at the one that, so typically we are going to choose the K value that maximize both values, the accuracy rate and the kappa value. Kappa is measuring what's so-called the inter-rater agreement or classification accuracy. It compares basically the agreement between two things, the observed classifications and the classifications that would be expected by chance or by random. So we're looking for high both when K equals 9. What is the misclassification rate? So the question says, I think the question asks, what is the optimal K? So the optimal K was K equals 9, based on the model K equals 9. So what does this mean? It means if I give you a new observation, what you're going to do, you're going to go to the grid, you're going to look at the nearest 9 observations, then you're going to classify this new observation. This is exactly what's going to happen. So you're going to look at the 9 closest observations. You're going to count which one have a social media, or what was the question, by the way? Or attended or responded to the campaign or no. So you're going to look at the 9 of them. So if the majority said yes, then you're going to classify this one to be yes. And you're going to look at the probability, by the way. So we can look at the probability, and we will look at the probability. What is the misclassification rate for the optimal K? When K is 9, the misclassification is 1 minus accuracy rate, right? Which is 1 minus 66%, which is 44%. This is the misclassification rate, right? After that, we are going to do the confusion matrix. The confusion matrix is something that we have done many times before, right? And we're gonna do the confusion matrix using validation dataset now. So the KNN, let's call it. Now what we are going to do before we create the confusion matrix, we have to predict first. We have to predict the social media for the validation data, right? Because we have a validation data, we would like to predict the response variable of the validation data based on the model that we have built from the training data set. So that's why we're gonna create KNN class first, classification, classified predict, using which one? Using KNN fit, use this model, and plug in the validation data into this. So that's it. You can call it new data before that, because it's one of the arguments. If you would like this one to be preceded by new data, that's okay, because look, it's a new data. Or you can keep it validation. I guess it works here as well. So it's going to predict now what's going to happen. So it's going to take validation data set, then we're going to plug these like in the KNN fit, the model that we have built. Then it's going to classify each observation of the validation. After that, we can create the confusion matrix. Confusion matrix. And if you remember the confusion matrix, we have KNN fit first. We have two things here. We have the no, not for the class, sorry. We have the predicted values, and we have the original value, the original social media, the original response. So we have the observed response, and we have, sorry, this is the predicted response, and this is the observed response, because the validation dataset has already social media column, right? Well, we already predicted these values because this model has never seen the validation data. That's why now we are comparing the truth with our model, right? So we're going to run this, we're going to run this, then we got the confusion matrix. Then this is the confusion matrix, and we can look at the accuracy is 62%. The accuracy is 62%. It's I guess it's higher than the. Okay. This is 62%. Sensitivity is really good compared to the specificity, which is, we have sensitivity, we have 77%. We have specificity is about 41%. Then we have the, what do you call it? The precision rate is 67% as well, right? So we have, overall we have, okay, we'll not look at overall now because we have many charts to look at. So let's keep this for now and move on. We're gonna assess the performance at the end when we finish all of the measures. Now we are going to do predictions, okay? So we'll be doing a prediction. The prediction here is, what we're gonna do is, we're gonna go to a new data and we're gonna classify them. The new data exists in a file called social media underscore score, right? So I'm going to call it my score. So this is my score. Run my score. I got my score. My score, we have 9 observations. We have nine consumers with income and age. We would like to classify these people. Are they going to respond to the campaign or no? This is the question. This is our concern, right? So we are going first to we are going to do what? We are going to classify them now. Now we have an issue, by the way. We have to be very careful here. To do the predictions, remember, I have my score, right? When we built the model we built it using my data, using training and validation partitions. They have both taken from my data one. And my data one already contains age and income from my data, but these are standardized age and income. So if you would like now, you give me new data. This is crucial. You give me new data set, which is my score. My scores, we have income and age, and they are not standardized. But the thing is, you cannot standardize them the way that you cannot look at these data and standardize them. These data and standardize them using the mean and standard deviation of these. No, these have to be part of my data one. It's a long story. They have to be part of these. They have to be somewhere down there. Then you standardize them to be the same thing, or they have to be here in my data. Then you standardize everything. Then you plug them into the model and classify them. And this is a long process to do this, the way that maybe the way that we have to do, the way, or let's say the very easy way. So what to do in this case? We are going to do something. We are going to use something that is easy, called pre-process function. The pre-process function, what we are going to say, we're going to say, hey, look at my data, and capture, look at my data, look at the income and age, and capture this, the mean, and capture the standardized values, or the standard deviation. And I would like you to go to my new data and, using the mean and standard deviation, standardize the new data, which is easy. It's like I give you the mean and standard deviation, then standardize these values. That's it. Very simple. Very simple. So what's going to be happening here? So I'm going to say use pre-process to capture the mean and standard deviation of my data. I'm going to call it processing. Pre-process my data, the original one. Don't go to the first column, the second and the third. Then use a method called a method called center. Capture two things, the center and the scale. Okay, processing. After that, standardize my score values using predict. This is easy. It's like we are creating the z-value formula here. Then we are going to plug in the z-value formula into the processing. So it's my score. It's going to be my score 1. I'm going to call it. This is the one that we're going to use. Predict. I'm going to plug what in what? In the processing, plug my score, simply. So plug in my score into this equation, processing, okay? What is the processing equation? It's the one that creates the standardized, the z-value, okay? So we got my score 1. Look at my score 1 now. This is my score 1, standardized, all of them. They have been standardized. This is perfect. After that, we can do the prediction. Now we're going to classify them. Now, classify the cases using KNN fit, right? I mean, using the model. This is the model, if you remember the model. So we're gonna say let's add the classification to the original data just to see. I mean, I'm going to add, this is my score, not the standardized score, it's my score. I'm going to add a new column, which is the predicted values, the predicted my social media response, right? Or people who, I mean, whether they're going to respond to the campaign, social media or no. So I'm going to go to my score. I'm going to add another column called social media, which is the one that I'm going to predict, use KNN fit, plug in my score 1 values, which is the standardized value, into the model. Then let's look at this. Let's look at the my score. Let's look at the my score again. View it. So run. My score is here. So a person who is $42,000, 66 years old, he's not gonna respond to the campaign. This guy is gonna respond with income 123,000, age 32, etc. So we have done the prediction now. We have done the prediction. Now we are going to jump into something important to create the gains and lift, the cumulative lift chart and decile-wise lift charts. To do this, we need the probabilities first, because these have been classified based on the 0.5 cutoff value. 0.5 cutoff value. What does it mean? If let's say we look at the optimal K was 9, so we looked at the closest 9 cases for each of them. For the first one, let's say the first one, we looked at the closest 9 cases and we counted them. We found that 3 of them, they said yes, they responded, and the 6, they did not respond. What is the ratio of 6 out of 9? It's like it's high, right? So this guy's not going to respond because people who have not responded have higher the probability than the people who responded than the 9 people, right? Out of 9. So that's why, based on the probability cutoff, if it's greater than 0.5, we're gonna get, it's gonna be classified 0 or 1. So that's why we have to create the probability first. So let's do the probability. So to do this, let's KNN classes, but we need the probability, not just classes, probability. Predict, and we have done this before. Go to fit, go to the model, go to the validation set. If you have done this, and we did this, we plug in the validation into the model, then the model classified these values and give me 0s and 1. No, I don't want 0s 1. I want the probability, so I'm going to change the type. So comma, I'm going to add another argument called type prob. Okay. And let's look at them, by the way. Let's see them. So these are the probabilities. This is the probability that the person is going to classify it as 0. This is for the ones, right? We need this one because we're going to plug this into the chart. So I'm going to pause here because this has been a long recording now. I'm going to pause, then we're going to continue the lift chart. We're going to create the lift chart, and we're going to create the AUC or the ROC chart as well.